What's up, chat? It's your boy XXX Jacob Law. I'm gonna talk about Roadrunner 1.0. I'm gonna preface this by saying that I'm not an expert in Roadrunner at all. I'm pretty trash, not gonna lie. The code I wrote this year is pretty bad, but this is just like kind of like introduction to everything. So I'm gonna assume that you already have all of the Roadrunner stuff installed already in like a standard FTC SDK repo, and you also have like Meep installed as well. So I'm just gonna run this program right here. All right. So let's start from the very basics. So in a traditional op mode, just using the standard FTC SDK commands, you would tell the robot, okay, move forwards 10 inches and then like strafe left 10 inches or whatever. But in Roadrunner, what you do is you tell the robot to move from this point to another point. So the Roadrunner turns the field into like a 2D coordinate plane. So you can see that the origin is the center of the field, and then you can basically create different points. Let's say you want to point like here, the starting point is like 18, negative 18, like around 56, and then the ending point here is like 0.36 or something, whatever. Um, so you can tell the robot to go from those 2 points, and then it'll create a path that the robot actually goes on to go from the starting point to the end point. So this meet testing class is like, I'm pretty sure this is just example code that I copied. So you create a Roadrunner meet bot. You set constraints for it. So T is just the length of one tile, so 23.5. And then here is where we actually create the path. So here, this is the initial pose. So pose is short for position and orientation. Position is the XY coordinates of the robot, and then orientation is the direction which the robot is facing. So here I set it to 270 degrees. Oh, and then this just converts it to radians because Roadrunner uses radians. So I'm telling the robot to face 270 degrees, which will be down, right? Assuming that 0 would be to the left, 270 degrees would have the robot facing down. And then I tell the robot to move in the spline to this new point, this new pose. Actually, it would make more sense if we started off with just something basic like strafe to constant heading. All right. Nope. New vector here. Alright, so what this code is doing is I'm telling the robot to go in a straight line from this starting pose to the end point. What? Bruh. To the end point, which is that, which is a 1, and then so rung y is just a variable equals 36. So if I run this, you can see that the robot moves in a straight line. So that's what strafe 2 does. It just has the robot move in a straight line from the starting point to the end point. And then if I do strafe to linear heading like this, and I set at the end like a random heading, so heading is like the same as orientation. If I run this code, you can see that the robot, as it's moving, is also turning to the heading that I tell it to go to, which is 180 degrees, which would be to the left, which is what you see happening in the Meet simulator. Right, so there's also strafe 2 spline heading, which is a little weird, but whatever. and there's also spline 2. Instead of strafe 2, you can do spline 2. So here I'm doing spline to constant heading, which means I want the heading of the robot, the orientation of the robot, to be the same throughout the entire path. And here it's setting the ending tangent of the spline. So this every spline needs a starting tangent and an ending tangent, which is basically um, the curve of the spline. I want the starting point. I want the curve to have the tangent line there be, oh, here it would be, I want it to be 270 degrees. And then I want the ending tangent, the end point of the spline, I want the tangent line there to be 180 degrees, which would be to the left. So you're gonna see in a moment. Yep. So at the end of the spline, the robot moves to the left because we that's what we set the ending tangent to be. So if I change it to like 0, you can see that the robot will now move to the right at the end. Right? And same thing if I set it to like 270, then it's gonna tell the robot to sort of like move down at the end. Like that. Right? And then yeah, so you can play around with it more yourself. So if you just want the robot to, let's say, just move forward and then stop and then score onto, I don't know, a basket or a rung or something, you would use the strafe 2, or you would have the robot go in a straight line. But if you want the robot to do like a complex movement, like I want the robot to go from the starting position, I want it to move down, and then I want it to go over here and then push these samples. It would be better there to use splines because you want the robot to move in a smooth, continuous path. And if you have the robot move in a straight line, like move in a straight line down, move in a straight line to the side, and move the straight line down, and move straight line to the side, and then push. Like you can see from that, like that would be a lot slower than if you just had the robot move in a smooth path without stopping at all. Go here, wiggle down here, and then push the sample. Right, so I think that's all I had to say for paths. So once you've created a path for the robot to go on, you also need to have the robot like move its different subsystems um, as well, right? Like you want it to actually like move its slides to like score or something, like move the intake outtake. So you would do that using actions. So I created an example action here called cool. And so this is just a constructor. I'm gonna assume you know what a constructor does. I'm gonna assume you also know like what the robot class does. Um, it basically just allows us to access like different subsystems. So in an action, basically all that's going on is you just like run code basically. Like this run function is where you run your code. Right? I have something basic here, like just set this power of the slides to 1. And what happens here is this run function is going to keep running until I return false. Here, this all of this code is going to keep running until the the slides motor's encoder position is greater than 500, right? Because once it's greater than 500, this Boolean statement goes from true to false, and so this all of this stuff will stop running. Everything inside the run method will stop running. So that's basically all that happens in an action. It's pretty simple. And then you need I don't know why, but you just need this. With every action you create, you need to create another thing down here. Right, and then yeah, so this initialize stuff here is everything that you want to run only once, you put it here. So let's say, I don't know, you want the at the beginning you want the intake slides motor, you want to set the power to 0, like you want the motor to stop at the beginning. You put that there, and then that code would only run once because, oh, once you run it, you set initialize to true, so this won't run ever again. Alright, and then in your actual autonomous, this is a specimen auto I made. Here I'm creating the initial pose using the pose 2D thing that this class basically that comes with Roadrunner. So yeah, this is the XY position, and then this is the orientation. And then I'm saying here, I'm using this trajectory action builder to create an action that runs the path that I created in meet. So I'm telling it to run this like strafe to constant heading, right? And then here I set the initial pose of that path to the initial pose up here. And then I have another trajectory action builder thing here. So it strafes to this, strafes to linear heading, and then the stop and add is it's running in action in the middle of my trajectory. So basically, after this is done, after it strafes to that point, I'm going to run this action, which is extend active intake. And then so you also have other options to run actions. This after the displacement. So it's saying after the robot has gone 12 inches, I want to run this active intake run action. And that is what will happen. Right, and then this is strafe to linear heading again, more stop and adds. So you can also do a after time. So you could say like after 10 seconds, I want to run an action. That's another way to run an action. All right, so once you have all of that, so I'm basically just I'm keep doing all of the move the drivetrain, run these actions using the stop and add, whatever. And then here at the bottom, I'm building all of the actions that I created using the trajectory action builder. And then actions.run blocking is where I'm actually running everything. Actions.run blocking basically just means run these actions. So I have a parallel action, which means I'm going to run this action, which is a sequential action. And I'm running this action. I'm running these both at the same time. And this robot update function is like updating all of the subsystems, right? Like, say I want to, while the robot is like driving around and doing stuff, I want the robot to always update the slides PID, right? That's what's going on in this robot update. Or I want the robot to like, to keep running the whatever servos, like constantly setting them to a position or setting the motors to a power. That's what the robot update does basically, right? So here, this sequential action basically runs this, and then when this action is done, I run this action. When this action is done, I run this action, whatever, right? And all of these actions are what I created above. Yeah, I think that's it. I think that's all you need to know for Roadrunner. I mean, as you can see, like it's not it's not coding the actual auto that's takes up the most time, I think. I think it's like really testing the autonomous and like getting it to be consistent, which requires like I guess you gotta like tune it a lot, and you have to tune Roadrunner well, I guess, and you also just gotta test it, like test the auto a lot. Like it takes a long time, like way longer than you expect. But okay, I hope this video was helpful. Bro, I need a glass of water right now. All right, see ya.